So what is fuel injection? Fuel injection is a system for admitting fuel into an engine, a separate system designed for admitting the fuel into the engine. It is a replacement of the carburetor. Okay, so it has become the primary fuel delivery system in automotive engines. Most of the automobile depend upon these systems, wherein carburetors are very rarely used in these days. In 1980s, 1990s, why 1990s up to 2000, carburetors were very popularly used in petrol engines for mixing the air fuel mixture. Later on, it was slowly replaced by fuel injection system. Okay. So the advantages of this fuel injection system is more uniform injection will be there. A uniform mixture will be formed, which leads to complete combustion of fuel. When the fuel burns completely, we have two advantages. We always get a better efficiency and the emissions will be reduced. So these days, emission norms are becoming stringent. Okay. BS6 implementation was a very big challenging task in our country. Automotive sector drastically came down. Okay. So last 2-3 years, you might have seen that was one of the major hit back for the mechanical stream also. Sudden implementation, the government had implemented directly BS6 from BS4. Okay. They are emission norms. BS4 has certain limits of emission, certain percentage of CO is allowed, CO2 is allowed. So BS5 was the upcoming one. So that was skipped by our country and directly BS6 was implemented. Okay. Now these days all the vehicles are of BS6 variant only. Suddenly the registration of BS4 vehicles was stopped. Okay. So to upgrade to BS6, a lot of automobile sectors had struggled. Okay. So that many popular companies only faced huge amount of loss. Okay. That was one of the major issue for the setback of our stream. Okay, so like that, in such cases, this fuel injection system advancements help in meeting the emission norms. Not only improving the efficiency, it also helps in meeting the emission norms. Okay, so what is the primary difference between a carburetor and a fuel injection system? Okay, so a fuel injection system automizes the fuel by forcibly pumping it through a nozzle. Similar to a diesel engine, a nozzle will be used here so that forcibly through a pump fuel will be forced so that you get finest possible droplets, so that a smooth mixture will be formed which leads to complete combustion in case of fuel injection system. Okay. The carburetor is replaced by a fuel injector and a pump, right, so that you get a better mixture which can burn in a better way as compared to carburetor. But what is the principle of operation of carburetor? You have seen very clearly in simple carburetor the Venturi effect. Because of the Venturi effect, the pressure drops suddenly. Because of the drop in pressure, what happens? Suction of the fuel takes place, so that it will be forming a droplets because of decrease in pressure. Okay. So the Venturi effect is the major contributor of the carburetor, whereas in a fuel injection system, a injector as well as a pump will be separately used. So this is the major difference between a fuel injection system and a carburetor. If a similar question is there, you can take a simple carburetor example. Okay, and you can draw a rough sketch and explain the principle only, not the components or the detailed working principle. I mean working procedure. You have to explain only the principle of operation. Okay, you have to highlight the Venturi effect and the airflow stream should be shown. Whereas in case of fuel injection system, you can take a MPFI. In the upcoming slides, we will be studying that sketch can be demonstrated and you can explain the differences between the two. Right. So please make a note of it. This is about the fuel injection system. So what actually is a fuel injection system, why it is required, and what is the difference between the olden day carburetor technology and a fuel injection system. Now we have to study in the upcoming slides about different types of fuel injection system, that is multi-point and single point. Okay, so please make a note of it. Okay, so mainly the manifold injection or fuel injection system may be of two types. One is single point and multi-point injection. See, in the single point, what happens? The sketch demonstrates clearly. In the single point, one or two fuel injectors are mounted inside the throttle body assembly. Okay, you can see this is called, this portion is called as the throttle body assembly. You can see, so these are the various, this is the cylinder head and there will be a number of cylinders. For example, in this sketch we have taken a four cylinder arrangement. Four cylinders will be there. So in the cylinder head assembly, a single fuel injector or sometimes two fuel injectors will be there. Okay, so air will be pumped in through a butterfly valve. There will be suitable air filters also. Air will be pumped in and the fuel will be sprayed here, similar to diesel engine. So air and fuel forms a mixture and they enter into the various ports. So whenever the inlet port opens, through that respective port, the fuel enters into the cylinder and it starts burning. Okay. So air enters from this point. Yeah, there is a idle valve also to relieve the pressure. So number of fuel injectors, maybe usually one or two fuel injectors for a four-cylinder engine will be used. So these injectors will spray the fuel into the flowing airstream, so that fine droplets of fuel will be formed, which will mix with the air and start burning. Yeah. So this is the first type. So fuel is sprayed at one point, or sometimes two, if two injectors are used at the center of the, usually if single injector is used, it will be placed exactly at the center of the cylinder head. You can see. Yeah. So this method is also called as throttle body injection system. This portion is called as throttle body. Okay. So wherein the throttling valve will be there, so that it is called as TBI, or a single point fuel injection system. For all four cylinders, fuel injection takes place at only one point, that is at the throttle body. So it is also called as throttle body injection system, or TBI technology. So these were there in olden days, but now this TBI is being replaced by MPFI, multi-point fuel injection. So please take down this sketch. Okay. Throttle body injection or single point fuel injection system. Please make a note of it.
Done, sir.
So next is the multi-point fuel injection system. Multi-point fuel injection system has a separate injector, fuel injector or a nozzle for every cylinder. See, as I told you, the last sketch, whatever we saw, it was a four-cylinder engine. So there was a common single injector for all the four cylinders. But here you can very clearly see, for each cylinder, there is a separate injector. That is the only difference. Air stream will be flowing here and it enters into the throttle body. There, the fuel will be injected by the injector so that it gets mixed with the fuel. Please take down the sketch.
Answer.
Okay. So multi-point fuel injection system will have each cylinder will have a separate nozzle for each cylinder, and the air stream will be flowing through the cylinders. At the end, the fuel will be injected to the cylinder. Okay. So delivering the fuel vapor close to the intake port ensures that it will be completely drawn into the cylinder. In the earlier sketch, we have seen that the fuel was supplied here, okay, in the throttle body. Okay. Sometimes when the inlet valve is open, because the inlet valve will be open for a very shorter period of time, the fuel may not be completely taken into the cylinder. But in case of MPFI, that problem will not be there, so that directly into the cylinder the fuel will be injected, so that there will be every chance that fuel completely enters into the cylinder, okay, and the complete combustion takes place. So that is the advantage of MPFI, and this is an improvement model over TBI, throttle body injection model, right? So next, these are all replacements of the carburetor. Earlier we studied about the carburetors. That technology is replaced by this fuel injection technologies. Okay. The next important component that we have to study is the fuel transfer pumps. Okay. So now, as usual, as we discussed, okay, these pumps are required for both diesel as well as petrol engines. Correct. So there are two majority types of pumps usually used. One is the mechanical type fuel transfer pump, and the second is the electrical pump. Okay. A fuel pump transfers petrol from the tank to the carburetor, fuel injection system. Maybe fuel MPFI you use or you use a carburetor, there should be some mechanism to take the fuel from the fuel tank and bring it nearer to the engine. Okay, that task will be done by the fuel transfer pump. Okay, so suitably fuel filter will be used, because if there are any impurities, they should not enter and damage to the engine. Especially in the MPFI system, there will be a small nozzle hole opening, so it should not block the nozzle hole opening. So a fine grind filter will be used to filter the fuel, increase the pressure and pump it through the pipeline. Okay. So sufficient quantity of petrol should be supplied, and the storage reservoir should also be kept in the carburetor to meet the fluctuations on the load. Okay. So usually two types of pumps are commonly used. One is the mechanical type. Mechanical type means there will be a diaphragm and a cam operated mechanism. Second is the electrical type. Okay. So there will be a electromagnet which actuates whenever the electricity is passed. Okay. So these two are the commonly used type of fuel transfer pumps. Okay. So first is the mechanical pump. Okay. Just take down the sketch, because we don't know which they may ask specifically in the exam. So each and every sketch you have to practice very neatly. Right. A sketch carries the maximum marks. So the first one is the mechanical pump. Okay. So coming to the working of this mechanical fuel pump. So it is operated by an eccentric or a cam, right? So what happens, this cam keeps on revolving, right? Depending on the timing that we have given. And whenever this part of the eccentric part of the cam reaches here to the rocker arm, this rocker arm will move down. Please listen carefully. This rocker arm will move down. Okay, so rocker arm will move down. You can see that the second part of the rocker arm is not directly connected to the pull rod. There is a pivot. Okay, so pivot. So what is the function of pivot? If the rocker arm moves down, the pivot moves up. If the rocker arm moves up, the pivot moves in the reverse direction. So when the rocker arm moves down, okay, so this will move up. So this pivot lever moves up, so that this position, so this whatever the pivot is there, it comes to this position, so that the vacuum will be created in this chamber. Okay, so the whatever mechanical device here, you can see that goes down because of this rocker arm, so that the spring deactivates and the diaphragm moves down, so that vacuum will be created. When the vacuum is created, the fuel will be sucked into the fuel chamber, right? So next, when the rocker arm, I mean when the eccentric moves back to the normal position, so this becomes again a straight assembly. Okay, so what happens again, this arm, whatever pull rod is there, this moves back to its original position and it will push the diaphragm. So when the pressure increases here, okay, so this is a one-way valve. It can allow only fuel to move in, it cannot allow to move out. So the obvious way to go out is the fuel will be forced, pressurized to this outlet valve. Okay, so this corely works on the eccentric. So eccentric keeps on rotating, so it will keep on operating the pivot rod, so that the rocker arm, which will be moving up and down. When it is moving up and down, this pull rod will also move up and down, so the diaphragm also moves up and down. Okay, so when the diaphragm moves down because of vacuum, okay, the inlet valve will be open. Okay, when the diaphragm comes back to its position because of high pressure, output valve will open and the fuel will be pumped out. Okay, so this is the working of a mechanical fuel pump. Okay, the main advantage is its reliability. Okay, there are no electrical components, it's a mechanical component. Okay, so once you install it, usually fuel pump, there will be no question of any issues, no wear and tear will be there. Okay, one major disadvantage is this type of mechanism should be kept very close to the engine, because it can generate only small pressures. Okay, so forcibly the fuel has to be fed into the cylinder, so it should be kept as nearer as possible to the engine. So this causes the entire fuel pump to get heated up. You can just open the bonnet of a vehicle and just feel the temperature, there will be very high temperatures. So because of such high temperature, fuel vapor lock will be a problem. It cannot be kept away from the engine. So that is the major issue related to the mechanical pump. Okay, so as we discussed, the most popularly used second type of pump is the electrical pump, electrical fuel pump. Just take down the sketch. Again, it also works on diaphragm principle only, but there will be no question of any rocker arm or eccentric. There will be no cam. Okay, this will be electrically operated. There will be a solenoid valve. Okay, so electromagnetic principle will be used here. Okay, again, same creation of vacuum. Okay, single side valve, all this concept will be same, only the principle of operation of this diaphragm is different. So please take down a neat sketch. See, as I told you, the principle of operation is little bit different. Otherwise, whatever task carried out by pump, this pump is same as that of the earlier mechanism. So there is a diaphragm from here. You can see similar to the mechanical pump. There is a diaphragm. Okay, so spring loaded diaphragm is there. So here you can see this dotted line is an armature. So as I told you, it works on electromagnetic principle. Okay, so there are two solenoids. Okay, and this central rod is there, you can see, which is directly connected to the armature. Okay, it's a spring loaded valve similar to the mechanical system. So whenever you switch on the ignition system, these two breaker points come in contact with each other. So there will be an electric field flowing. Because of that, So this whatever armature is there, that will move up and it will hit this wall. Okay, whenever this hits the wall, the breaker whatever breaker points are joined initially, okay, they get separated. So when they get separated, again the magnetic field comes down here. So again the whatever armature you see, it comes back to its original position. So it will be moving up and down continuously. So whenever the breaker points meet, it will be pulled up, it will hit this wall. Whenever it hits, it will be broken. Again, this will move up, again these two will meet. It's in a continuous process. So whenever this armature moves up, what happens? The diaphragm also moves up so that a vacuum will be created here. So when the vacuum is created in this chamber, the inlet valve opens and the fuel will be taken in. Right. So by the time the fuel enters, again this rod will hit this position, the breaker points will break, the electromagnetic field comes down, so that again this armature comes back to its original position. When the armature comes back to its position, the diaphragm moves down, so that pressure increases here. As usual, this is a one side wall. It cannot move to the fuel cannot move back here. So obviously the fuel has to move forward in this direction. So this is the working of a electrical pump. Instead of a rocker arm and a eccentric, here solenoid valves and an armature are used. Otherwise, the arrangement is almost same. So the next question comes is, why should we use this mechanism? Okay, when the mechanical fuel pump itself is a very reliable mechanism, it can work without any maintenance issues. Why should be used? The major problem with the mechanical pump is it should be placed very nearer to the engine, as the pressure developed will be very low. Okay, so that the pump will be subjected to high temperatures, the vapor lock of fuel. Okay, in local language they say that rich. Okay, moped, when you take it for service because of starting problem, they say rich agide. What do you mean by that rich? Okay, there will be a vapor locking of fuel. So that locked fuel the vapor pressure should be released in order to start the engine. So this issue occurs at high temperatures only. So in order to avoid that, electrical fuel pumps are used. They can be placed very far away places from the engine. Okay, you can place it away from the engine, so that this will not be subjected to high temperatures. So the fuel vapor locking problem can be eliminated. So this is the working of an electrical fuel pump.